Okay, so you've grown your business to the point where your customers are actually complaining about how slow your system is now. That's actually good news because that means that your servers are starting to get loaded with customer utilization. The downside or the bad news is that now your engineers have to figure out how to make it faster. Well, the place to start, sort of the low hanging fruit, is almost always caching. And in terms of approaches that are easy to access for caching, well, one of the easiest is local caching. Very easy to implement, whether this is in Python, JavaScript, any language, .NET, Java, whatever. Local caching is nothing more than a local map or dictionary style structure, and you can use it as sort of a local global. Put data in that all users might commonly use. There's oftentimes a lot of shared data that's not user specific, and cache that way, or even do it on a user specific basis and store that data locally. The upside of local caching, instead of say going to a database where maybe a long running query is going to take a second or many seconds, typically from a local cache, you're talking about microseconds for access. So it's basically instantaneous. You can see huge performance benefits initially when you bring this into play. And so that's sort of the low-hanging fruit. The next layer beyond that would be distributed caching, and as shorthand for this, I'll just say Redis, one of the most common approaches. And you've got providers like Amazon, like AWS, with Elasticache, which is essentially their version of Redis. But Elasticache, Redis, those kinds of solutions, what are they? And they are distributed caches. And there's a lot of benefits to those as well, because once you're running multiple servers, and maybe a user, their first request to your system, whenever they're on a certain page on your site or whatever it might be, it might get processed by server number 1. But then the next request might be on server number 2. There are ways that you can pin and route users to the same server every time. But if you have a distributed cache where information that is relevant to that user is spread across, it's accessible to all servers, then it doesn't really matter. Now, the difference between local caching and, say, something like Redis is that maybe local caches can work in microseconds. With Redis, you're talking about more like on the order of double-digit milliseconds. So it's still easily 100 times faster than going back to the database, but it is going to be a little bit slower than the local cache, and a little bit more work since obviously there's some infrastructure to set up. Now, the fastest caching approach of all actually takes us back to the local, and it's not even available now. This one is not actually available in all languages, or you'd have to do some hijinks in some languages, but I'll call it local typed caching. And so for compiled languages, so say .NET, Java, Python via C or C++, so I'll say via C++ if you want to get into this. There are ways, to do this. Essentially, what is this? Well, I'll give you a concrete example and show how performant this is. So my last startup, Hidden Levers, we needed to store large amounts of financial data, and we needed to access it very rapidly. And for a particular use case, this was calculating the cross correlations across every stock in the United States, or not even every stock, actually, stocks, mutual funds, a broader set of assets. So literally something like 100,000 different securities, and we needed price histories, for these securities going back years. So if you needed to go to the database to get that price history for each and every one of those 100,000 in order to then compute, well, a couple of things would happen. Firstly, if you try to get all of that data and you store it inefficiently, like in a typical way, like a Node.js type application or even a typical Python application would store that, you would blow out your server memory. So you couldn't do it anyway. Or you might struggle, with that absolute volume of data. So you got to store the data in a more efficient format. That becomes key. So in that case, we were in Java, and what I actually did was used arrays of floats. So using arrays of floats, those are very small. I was actually able to pull all of that data into memory in around about 100 megabytes, which is a relatively small amount of memory when you're talking about a server that might have, I don't know, 16 gigs or something like that. So taking that approach, then we're able to do all those calculations in real time, in memory, which made them instantaneous. You're getting the same speed that you get up here, down here. So again, microseconds, but by using typed and compiled objects, you're also taking very little space. So that's the one advantage that you may be able to, to grab by using one of these more old school type languages, or by using bindings into a compiled language from Python. From the Node.js world, it's possible as well. You might just need to take an extra step and call out to something written in one of these other languages so that you can actually access that sort of memory efficiency. But regardless, the low-hanging fruit for optimization of your system overall, it's caching. Stop calling the database every time. Start using stuff in memory.